Hello, this is Gareth Keane. I'm continuing the series of videos for VBA programming in Excel. The one we're going to look at today is the Maclaurin series for y is equal to exponential x, how we're going to implement that. We actually did it last week, but in that case this is the Maclaurin series for y is equal to exponential x. And it's basically an infinite series that goes, the first term is 1, the next term is x, the next term is x squared over 2 factorial. The general term is x to the power of k over k factorial all the way up to n. Now when we did it last week and we implemented it, you can see that it can be expressed in a single summation statement like the one seen here, and this can be implemented in VBA code. And the example we did last week was we used a definite loop, a for next loop, and we implemented this particular summation using a for next loop. If I do a quick recap on last week's code, we had variable k, which is the loop counter, which term you were actually calculating. X was the value of the variable for which you were getting the exponential, so exponential 10 say. Term was each time, term basically is the variable to use to store each term of the series, where a term is one of these things here, like x to the power of 4 over 4 factorial. Exponential x is the double to store the result, and n in that case was the number of number of iterations you were going to carry out. So if you remember, using a for next loop, you say for k is equal to 1 to n, and you have next k down here. So it's going to run through these statements where you calculate each new term, you add the term to a running total exponential x, and you output the term and the running total to a new line and an output string. When the loop is finished, you put the output string onto the text box on the form. Now this is known as a definite loop because before you go into the loop, you know exactly how many iterations you're going to carry out. In this case, if the user puts in a value of 10 for n, you're going to do 10 iterations and calculate the first 10 terms of the series. What we're going to do is, the problem with this is it's not the most efficient way to carry out a summation like this. You may converge on the answer after 5 iterations, but if you actually calculate 20 iterations, you're wasting computation time. On the other hand, you may not actually go for enough iterations and you don't know if the solution has converged. By convergence, I mean that after you've added up all these summations, if you were to add an extra one, it would make no difference to the answer, or very little difference to the answer. We'll see that in the next example. In this case, we're going to do the same problem, but we're going to solve it using a do until loop, which is known as an indefinite loop. An indefinite loop means before you go into the loop, you don't know how many times you're going to run through the loop. You have some condition at the end of the loop that will test to see if the solution is converged, and are you ready to exit the loop. So the short program will first ask the user to input x and the tolerance, which is used to determine the accuracy of the result. A default value of 1e to the minus 7 is set. As the program iterates through each loop, it calculates each term of the series and answer to the variable exponential x, which holds the result. So that's the same as the last time. As more terms are added, the result will converge to a constant answer. You saw that when you did it last week as well. After 20 iterations, it was already converged. In fact, after 15 or 16 iterations, the exponential of 2 was converged. This occurs when the result from a new iteration differs. The result will converge to a constant answer. This occurs when the result from a new iteration differs from the previous result by a value of less than the tolerance. So that's going to be the test that determines if you're going to exit the do until loop. As before, the program adds each new term and the value of exponential x to a string variable, which is output to a text box after the loop is completed. So we have our variables here. We have k, which is the integer loop counter to specify which term is calculated. We have x, which is doubled, which is the value of x to be used in the function, so the user puts that value in. Term, as before, is the double to store the value of the term as is calculated, and that each new term is added to the running total exponential x. So that's the double to store the result. We have a variable temp. It's a double to temporarily hold the value of exponential x from the previous iteration. And you'll see why that's necessary when we're looking at the test to exit out of the loop. Tolerance is the integer to store the number of terms of the series to be calculated. It's set by default but can be changed by the user. And we'll see that as we run through the program. Output string is the string to store the list of terms and the running total exponential x, same as before. So the pseudocode goes as follows. Initialize exponential x equal to 1 for the first term corresponding to k equal to 0. We did that before. In this case, there's an extra step. Initialize k equal to 0. So we set the initial value of k equal to 0. Then when you come into loop, the very first thing you do is you iterate k or imp k for the next term. So k is now equal to k plus 1. Store the value of exponential x from the previous iteration. So you need to do this so you lose that value. So you say temp is equal to exponential x. Then as before, we calculate the new term for the current value of k. First time through loop, k will have the value 1 because it's 0 plus 1 is equal to 1. So we'll have the value 1. So we calculate the first term. We add the term to running total exponential x. So as before, we add it to running total. But now what we do is we calculate the absolute difference between the previous and current values of exponential x. If you remember, before we calculated the new value of term and added it onto exponential x, we stored the previous value in this temporary variable here. So now we're able to get the difference between them, and this will give us an idea if the solution has converged. Now in this case it doesn't really matter, but in other cases you can have negative or positive exponential values of the series. So you need to use the absolute function, and that makes it positive. Even if it's a negative value, you will make it positive. You output the term exponential x and diff to a new line on the output string. So also in this case we're going to output the diff. Now this is the important thing. You have a do at the start of the loop and a loop until the diff is less than the tolerance. So it will continue until the solution converges. Now, and the last thing you do once the loop is finished, display the output string in the text box as before. So a lot of this will make a bit more sense when you actually look at the code and how we implement it. So that will be in the next video. Okay, thanks for listening.